Hi, all right, we are doing potential energy diagrams. Okay, so it's just like literally drawing a diagram, a picture of the energy, potential energy of a chemical reaction. All right, so we're going to just really focus on the picture. So if we go down here, we really want scroll down here. We really want to be able to label all the parts of like an energy diagram. And we looked at elephant's toothpaste. So we said, okay, so first, if you have a reaction, you're going to start out with a certain amount of energy, not much happening. It's just like level. And that is the energy of the reactants. And sometimes instead of just labeling it A like they did, they'll say, okay, well, this much, that's A. And they'll label it like that, like from here to here, that is A. So sometimes it'll be labeled like that. So A is just the energy of the reactants. That's how much energy they start with. All right. And then we start going up and we say, okay, well, to get this reaction started, you have to get up here. So just like our elephant's toothpaste, we had to like drop a chemical in to get it started, or like a combustion reaction where you have to just put a little flame to ignite it. But once you get it, that spark, it's going to like poof, do a big flame. So sometimes you just have to like do a little bit to get it started and then it goes on its own. So that energy to get it started, to get it activated, is called activation energy. Okay, so we're going to say from here up to here, from where you started to where you had to get activated, we're going to call that E, activation energy. All right, the energy it takes to get started. Sometimes, since it's so crowded over here, they'll like kind of bring it over here and they'll say, oh, this is E. And sometimes that confuses people because they're like, what's this thing over here? Well, if you just follow it over, that's still the distance between where you started and where you had to get started. All right, next, let's go to this right here, this max. So if we were to kind of draw it just like all the way to the max, sometimes people think this is the activation energy. Nope, the activation energy was back over here where when you went from where you had to start to where you had to be to get going. The energy of the total thing right here, this is B. This is the energy of the activated complex. So we're going to say like once the two chemicals got together, before they kind of did whatever they're going to do, they kind of temporarily got stuck together in this like super high energy thing. So picture this is like when the elephant's toothpaste was like sprouting out. Like this is like the max energy. It's activated. The two chemicals are stuck together. Like a housing complex, the houses are stuck together. The chemicals are stuck together in a complex. Okay, so right here is where the chemicals are stuck together. And so we're going to call that the energy of the activated complex. They're activated, they're stuck together, they're going. Okay, so you have to know that one. That's one of their favorite ones to ask, and people get that mixed up with activation energy. Next one, let's call it pink. We are going to say that this right here, it's like, okay, reaction's over, it settles down. Sometimes it ends up higher than it started. Sometimes it ends up lower. In this one, it ends up lower. This is like your products, right? And that kind of makes sense. So what's that? Energy of products, D. All right, so you started with reactants and you end with products. You read left to right. You start with reactants, end with products. All right, so that one kind of makes sense. And then the hardest one, and of course their favorite one to ask, would be, let me pick another color. How about light blue? The delta H. All right, so you're gonna want you to know delta H. So delta means like change, H means heat, so heat's like a form of energy. So it's just saying like, what's your net change in energy? And that's gonna be the difference from where you started to where you ended up. So I say it's like if you had a little lemonade stand or a fundraiser. If you spent $20 to begin with, and then you only ended up down here with $10, that wasn't a very good, successful lemonade stand or fundraiser, okay? You actually had a net loss of $10. All right, you went from 20 down to 10. All right, so it's like a net gain or loss. So this right here, the difference between where you started and where you ended, we are going to call that the delta H, and that is C, the delta H, or the change in energy. And that is one of their very favorite ones to ask. So I would give that a nice little star. And it's also a harder one to remember. Their other favorite is activation energy. All right, so that is it for that. Make sure you know all of those parts of an energy diagram. That'll be a lot of easy questions on the test.